everyone, and welcome to Learning During Lockdown. Today, the topic that we're going to study is direct proportions. Direct proportions. So, if we're going to divide this video into a few parts. The first one would be the introduction. The second one will be us going through an example, and in that example I will share the steps that we will be following to solve direct proportion questions. And then in the third part of the video we will be solving two additional examples. So that's the overall structure of this video, and I've put in the timestamps within the description of the video, so you can skip through to the part of the video that you want to watch. So let's start with the first part of the video. Well, I'm gonna change the color because I don't know, red seems too boring. Let's go with this purple. I like this purple. Okay, so as I just shared, the first part of the video is the introduction. Okay, so what exactly is direct proportional, or which two quantities are said to be directly proportional to each other? Like, we get so many questions, right? Like, what exactly is direct proportion? Direct proportion, what two quantities are said to be directly proportional? So, to answer these two questions, essentially two quantities are directly proportional if they're always in the same ratio. So what does it mean to be always in the same ratio? It means that if they're divided by each other, they will always produce the same ratio. Okay, that's exactly what that's exactly what the fact that they're always in the same ratio means. So we're going to write that down with a different color again. So two quantities are directly proportional if they are in the same ratio. Additionally, green color now. So additionally, we can say that if two quantities are proportional or directly proportional, then dividing them by each other will always produce the same ratio. So and how exactly do we represent this in written form? So T is directly proportional. T is directly proportional to L. This is how we express it. T is directly proportional to L. Now there's another thing that comes into play. It's like if we write t is equal to k into L. Now what is k here? K is called the constant of proportionality. Now there are two important things that we need to consider here. Let me write them down. The graph of a proportional relationship is a straight line through the origin. This will always be true, yeah? It's one of the facts that always stands true. The graph of the proportional relationship is a straight line that passes through the origin. And there's another thing. The gradient or the slope of this graph is, drum roll, what do you think it is? Well, it's equal to the constant of proportionality. It's equal to none other than k. And as we know, k is the constant of proportionality. Cool. So according to our plan, we are done with the first part of the video, and we're going to move on to an example where we'll also discuss the steps to solving the questions of direct proportion. Okay, so the second part is we're gonna do an example plus discuss the steps, right? Okay, let's jot down the example. Let's just come up with an example like, okay, so let's say that u is directly proportional to I. Okay, now the question wants us to fill in the gaps in the table below. Let's do it. So let's make the table. We're going to write the values for u above and those for I below. Okay, so the question will give us the value for both for one instance, right? So when u is 4, y is 2, so we have to fill in the rest of the table. What's I when u is 1, and what's I when u is 2? Let's do this. Okay, now we're going to focus on the steps. So let's change color. The first step is that we will convert the proportionality statement into an equation. So what does the statement say? The statement says that u is directly proportional to I. So u, we know that the proportionality sign is this, is directly proportional to I. Now we'll add in the constant of proportionality. So our general equation is u equals ki, right? So the step 2 is to add into the above equation the values for u and I to find the value of k. So let's do that. So we have that u is 4 when I is 2. So when we add in the values within the equation, because our equation is u is equal to ki, so the value for I is 2, so we have replaced it with 2, and the value of u is 4, so the equation is 4 equals 2k, and then as 2 is being multiplied by k on the right side, when we take it to the left side it will be divided, so it will be k equals 2 or 4, so essentially k is equal to 2. Step 3, form a general equation using the value of k. Let's do that. So it's u equals ki, so we know the value of k, so it will be u equals 2i. Perfect, we have the general equation now. Great. So now we can use this general equation to solve any question that they throw at us, any kind, any question, because you have the general equation, you can always plug in the unknown to find, you can always plug in the known to find the unknown. So for example, let's try the first one. Let's try to find this value. So what is I when u is equal to 1? So u is equal to 1. What is I? Let's solve it for this. U equals 2i and u is 1, so what is I? 2 and I are being multiplied, so we'll take 2 to the left side. 1 divided by 2 is equal to I, hence the value of I is 1 over 2. Now let's do this. Okay, so we know that the value, for this, where's my pen? Yeah, so you know the value for this. Now we're going to solve this. Okay, so what is I when u is 2? U is 2, find the value of I. Writing the equation over again so that we don't get it wrong. It's very important to write the equation again so that essentially reduces the chances of error. So 2 and I are being multiplied, so we'll take it to the left side, so it will be divided by 2, so I is 1. When u is 2, I is 1, and when I is 1, u is 1, I is 1 over 2. Perfect. So we are done with the second part of the video, and now the third part of the video is to solve 2 additional examples. Okay, let's start by changing the color of the pen, which is my favorite thing to do. Okay,